Hi. Oh, don't know what just happened. Oh goodness, what did I do? There we go. Hi guys. Sorry about that. Um, we're gonna go ahead and go into day 4 of Unit 7, which is factoring trinomials. So last video, you guys learned about how to factor out a GCF, greatest common factor. Now I'm gonna show you how to factor out a binomial, basically. Okay. So let's go ahead and get started. So let's do a quick review. Factor this 2x squared minus 4x and see what you can do on your own. So pause the video so you can actually see if you got it, and then we can talk about it, okay? Go ahead and factor. Okay, so hopefully you were able to factor something out, and let's see if you were right. So the very first thing, like when we talk about these and we want to factor out a GCF, we want to see what the two terms have in common. That means you have to look at both the numbers and the variables. So the numbers are 2 and negative 4. What can I divide both 2 and negative 4 by? I can divide them both by 2. Oop, didn't mean to show you the whole answer, but hey, now you got it. Then I look at the x's and see what I can factor out from them. So this guy has 2 x's and this one only has 1, meaning the minimum number I can take out is 1x. So I take that out and put it in the front. That's my GCF. Ooh, sorry for the whistle. That is my GCF. Now I gotta figure out what's left over. So if I divide this guy by 2, I'm left with 1. If I take 1x away from this, I'm left with 1x. So the first term changes to 1x, or just x. Then I divide negative 4 by 2, I'm left with negative 2. And I take away this single x that they have, and that means they don't have any left, so they're just left with the negative 2. Now please be careful because you need both the GCF that you factored out, the monomial that you factored out basically, and what you have left over, okay? Whether it be a binomial, trinomial, however big it is. You need to have both of these for your answer. I will rarely ask you what is the GCF, in which case you would just give this. Mostly I'm going to say factor it, which means I need to know what two things got multiplied together. Okay? Alrighty. Let's start on the stuff. So to factor a trinomial, I'm going to warn you right now, this might be a little hard to follow in a video, but that's okay because next week we'll be doing a lot of practice in it. So just make sure you are ready with lots of questions, and we will make sure that you understand it by the end of next week for sure. Okay? When factoring a trinomial, though, your very first thing is to factor out the GCF, if it's possible. If they have a GCF, you should factor it out, because then what it does is makes your trinomial have smaller numbers, so it's a little bit easier to do. Okay? So if there's a GCF, factor it out, because that is one of the factors that needs to get multiplied together to create your trinomial. Step 2 is to factor by grouping, and I'll tell you what that is in a second. And that's it. That's how you factor a trinomial. So let me go into more detail about what factor by grouping is. Okay, so to start this off, you guys remember when we did the box method? There were 4 boxes, or however many boxes there were. Typically, we're going to deal with 4 for factoring purposes. And then we combine like terms to create like a 3-term polynomial, right? To create our trinomial. But there are 4 sections. So what we're going to do for factor by grouping is we want to go back to those 4 terms that we kind of merged together. Because when we have 4 terms, we can group it off into 2 binomials and then just take GCFs from each of them. And make it a lot easier to basically undo distributive property then. But we can't do that unless we have 4 terms. So that's what factor by grouping does. We get those 4 terms, and then we can undo distributive property. So step 1 is to create what I call a magic X. Okay, and you're going to hear me use that all the time. Okay. What the magic X does, it allows you to figure out what the middle term can become. So we're trying to split the middle term into 2 terms, because the middle term is what we combined like terms to be. we can use this magic x to figure out what those two middle terms can be. Okay, so generally this is what a trinomial looks like. So sum a term, like number times x squared plus some other number times x plus some other number. So your magic x, you would just draw a giant x. In the top, you would do whatever a times c is. Okay, and in the bottom, you would just put whatever b is, the numbers, just the numbers, not the terms. Okay. You're then trying to figure out like what two numbers will multiply up to this, whatever this number is, and also add up to this number. Okay? So you're trying to fill in these side ones with those two numbers. Because these question marks are the two terms that you could replace the bx with to create four terms. Okay? I know it's really hard to explain and understand just from this. When we do examples, it should become a little bit clearer. Okay? Step 2 is to take those two numbers that you found and replace the b with them, so to create like two terms instead of one. Step 3 is to group the terms. Oh, so here, sorry, step 2, so it'll look like this instead. Instead of just one term here, we split it into two. So then we go ahead and group the terms. So we're going to group them into two binomials. So it'll look like this. Sorry, all my parentheses. So then we have a binomial plus a binomial. And we factor out our GCF, whatever they have in common. And then we can factor whatever GCF they have in common. They should have the same leftovers, which means we could factor that out again and create our two binomials. And then we just write our two binomials. So let me show you an example, because I know that's hard to follow with just steps. Okay? So here's our first example. We have 2x squared minus 9x minus 35. Okay, so the very first thing we're going to do is there a GCF? 2x squared minus 9x minus 35. Okay, so can I divide the 2, the negative 9, and the 35 by anything? Well, the only thing I possibly could is 2, because that's the lowest number I got, and 9 and 35 are not divisible by 2, so that won't work. Then I look at my x's. This guy's got 2, 1, nothing. So they don't all have the same x's to give, which means there's no GCF. Okay? Remember, if you find something in common, they all must have it in common. Okay? In order for you to take it out. So now I'm going to go ahead and do this, factor it by grouping. So the very first thing I do is create my magic x. So, didn't mean to show you that, but that's okay. Alright? In the top, I'm going to do what a, which is 2, times c is, which is negative 35. So 2 times negative 35 gives me negative 70. So that's what I need to find two numbers that multiply up to negative 70. And on the bottom, I'm going to put my b term, or my b coefficient, which is negative 9, down here. And that's the number I need my two numbers to add to. So this is the longest part where you're trying to figure out what goes in it. My suggestion would be to start with whatever you're multiplying. Just start working with numbers, like what multiplies up to 70. You could do negative 7 and 10, but that won't add up to negative 9. You could do negative 10 and 7. That does not add up to negative 9. You can do 2 and negative 35. Doesn't add up to negative 9. So there's a lot of guessing and checking going on. Okay? And it will take time. You just got to do it. There's no way around it. There's no shortcut for it. You just got to do it. Okay? So you keep going, keep going. What about 14 and negative 5? Well, 14 and negative 5 gives you positive 9. So if you get the number but not the right sign, just change the signs of the two numbers. So I said 14 and negative 5. Let's change it to negative 14 and 5. It multiplies up to negative 70, but it also adds to negative 9. So those are the two numbers I'm going to replace negative 9x with. Okay, so now I have 2x squared minus 14x plus 5x minus 35. And it does not matter the order that you put these two in. Now I have, oh sorry, that was step 2, to replace it. Now I can group it because I have 4 terms. Okay, so the first group, I'm just going to do the first 2 terms. Okay, that's my first group, and the second group is the last 2. Now I'm going to work with these binomials separately and find out what GCF they have in common. Okay, so I look at 2x squared and negative 14x. Well, both of these can be divided by 2, 2, and they both have at least 1x I can take out. So I go ahead and take out the 2x from both sides. Oh, I didn't mean to show you everything. And I'm left with x from this one, because I just divide by 2, I'm left with 1. Take one of these x's away, I'm left with an x. Divide this guy by 2, I'm left with negative 7. Take away that x, no more x there. And then I do the same thing here. What do these two guys have in common? They both can be divisible by 5, so I take out that 5. They do not both have an x I can take out, so 5 is the only thing. And I just divide. 5x divided by 5 gives me x, and negative 35 gives me negative 7. So now do you see how they both have the x minus 7 in common? That means I can factor that out. And I want to use a marker for this. Okay, a different color. So I'm going to go ahead and take what they have in common. They have this and this in common. So I can undistribute that. I'm going to factor that out. So that's going to go to the front. And that's going to go to the front as well. Okay. Sorry, I kind of forgot to show you these stuff. So we factor the GCFs here. And now that we have another GCF, they have that binomial in common. I'm going to factor that out as well. If I take this x minus 7 and put it in the front, the only thing left here would be the 2x. And the only thing left here would be the 5. So now I can just write out my binomials. The x minus 7 is what I pulled out, and this was what was left over when I took it away. So these are my 2 binomials that I got by factoring, and these are what got multiplied together to create that trinomial at the beginning. The 2x squared minus 9x minus 35. Okay? So, I know. Just a little bit. I told you, it makes a hard left. Everything was really easy at the beginning, and now it's like, Wah! Okay? So let's get back into full page mode. But you could see like all these undoing of distributive property. Like we're just pulling little things out at a time. So it looks a lot like the distributive property when we did multiplication. Okay? So you guys are going to try this one on your own. Make sure you look for a GCF first, and then try factor by grouping. Okay? And we will go over it next time for sure. And you're going to do this one on your own as well. Look for GCF, factor by grouping, magic X, all those fun words. Okay? Now let's talk about example 2. So here we have one that doesn't quite look like our trinomial. This is actually only a binomial, but because it's a quadratic, meaning it's got a degree of 2, we can make it into a trinomial. So anytime you have a degree of 2, you can put in or degree of whatever, you can put in those missing terms that you need. So we have to factor this. We want it to be a trinomial. Okay, so I am missing that middle term, the bx. I'm going to write it with a 0 for the b then. Okay. And now I'm going to go ahead and figure out the factoring process. So I make my magic X, first I look for GCF. Is there anything in common? No, because I can't pull anything away from 1, 0, and 5, and they don't all have X's, so there's no GCF. I now make my magic X. I need to multiply to be A times C, so this is a 1 here for A, and C is 5. So I have to try to multiply up to 5 and add up to whatever B is, which is 0. So to multiply up to 5, you can do 1 times 5, but that doesn't give you 0. And that's really all you can do to multiply up to 5. Or negative 1 and negative 5, but it still doesn't give you 0. So there's nothing that actually works to fill this in, which means it cannot be factored. So you would just leave it as is. Please be careful though. Just because you can't find anything does not automatically mean it's going to be unfactorable. You need to make sure you try every option first before you make this judgment call. Okay? So, I would just leave it as is because I can't figure it out. Now, when I can't factor, these are called prime polynomials. They cannot be factored at all, not even with GCF. If you can factor out a GCF and not do the magic X, it's factorable, just not very factorable. If you can do the magic X but not GCF, it's still factorable. Prime is when you cannot do like anything at all. Okay? So, and then the last thing is just special cases. So we have x squared minus 9. We have to factor it. Now this, like we said, this is a special case. This is called the difference of squares because you're doing a square, x squared. It tells you it's squared. And then 9 is a perfect square as well. So if you remember, this was a special case. A minus b times a plus b will give you a squared minus b squared. We have that. We have the first number squared and the second number squared. We could work backwards. So this is where using the shortcut is very, very helpful. Because you could just create it to look like a squared minus b squared. Instead of writing 9, I'll write it with a square, which means I just need to square root this. So I could write it as x squared minus 3 squared. And then fill this in, knowing what a and b are now. So I would get x minus 3 and x plus 3. Now, if you don't want to memorize this or you forgot it or whatever, that's totally fine. You could still do it the normal way as well. Because it's only a binomial and we're missing that bx, we're going to fill that in with a 0. Okay? There's no GCF I can pull out, so I just go ahead straight in there. I'm multiplying 1 and negative 9 for the top, and 0 is going in the bottom. I have to multiply up to negative 9, but add to 0. To multiply up to negative 9 would be 3 and negative 3. And they actually add to 0 as well. So instead of 0x, I'm going to put 3x minus 3x in the middle. Right here. So these were the ones I replaced it with. Now I can go ahead and group it. And then I can work on each one and factor out a GCF. So these guys only have an x in common, so I pull that out. And if I take an x away from here, I'm left with x. If I take an x away from here, I'm left with 3. This guy, I can pull out a negative 3. Remember, you always want to try to have your leading coefficient be positive. So if there's a negative there, try to pull out a negative number. I could pull out a negative 3, and I'd be left with an x here and a positive 3 here. Okay? Now, luckily the leftovers are the same, which means I could factor those out as well. They're the GCF for that now. And pull those to the front. So x plus 3, which I just put in the back for some reason. And if I take the x plus 3 away from each one, I'm left with x minus 3. Same deal. Exact same answer. So it's up to you if you want to use the shortcut or the longer way. It still gets you there. Like me personally, I just use this because it works for any kind of situation. Where these, you have to be very aware of the situations they work in. But that's it. Please, if you have any questions, write them down. You guys can email me, remind101 me if you have more immediate questions I can help with. Otherwise, we will practice this a ton in class next week, so we'll get you there. Don't worry. Okay? Bye.